So now I'm going to make a small movement, adjust my focus, make sure I don't have any parallax in the crosshair. And then I snug this screw down, and then I check my level. Good that direction. And good that direction. Now, some other things about this instrument. This thing has a lot of scopes. We have the optical plummet scope. We have the main scope, which we view, and we twist the eyepiece to focus the crosshair. We use this silver ring, and if we twist that focuses the objective. We also have a small scope. This little scope is how I read the horizontal and vertical rings that are internal. You can't see those. You can only see the projection of them through this vernier scope. To be able to see those, I have to open this little doorway, and it's a mirror. And I will take sunlight or a lamp, and I can spin this in any direction, and I shine light into the hole. And then when I look through the small scope, I will see two scales. The above says V for vertical, and the lower one says HZ for horizontal. I then need to set my instrument to 0 degrees, which on the lower scale, and I'm working with horizontal angles only, I set my instrument to 0 degrees horizontally. I lock this lever down. Now in the class instruction, we will actually show you how to read the vernier. We can't illustrate that with a camera because we can't see inside the instrument. Now when the lever's down, whatever angle I have set in my instrument, it stays there. I can now unlock this horizontal lock. I can move the instrument wherever I want. And if I look through this little scope, it's set at 0 degrees, and that's my starting point. So now, if I want to target something, on the very top of the instrument main tube is a little optical sight. So I'm going to use this, and I'm going to target an object. And when I look through this optical sight, I will see an illuminated white crosshair. I get it close, and I lock this horizontal lock. This is the vertical lock, and this is the horizontal. So I move the tube up or down until I get close. And I lock this, and this is locked. Now this is what we call a tangent screw. If I look through the instrument, I first have to get my crosshair focused as crisp and dark as possible. Then I use the silver ring, and I get my objective focused. And then I'm going to move the tangent screw. If I, with this horizontal lock, when I use this screw, it moves it horizontally, very smooth motion. So I can actually move my crosshair horizontally in a very smooth fashion. If the vertical is locked, then this is the tangent screw that moves the tube up and down in a very smooth motion. So I can move my crosshair up or down until I get exactly on my target. Now, probably one of the most important aspects of making angle measurements or laying out for an angle is sight picture. We must have the crosshair parallax eliminated. We must have the objective perfectly focused, and that crosshair needs to be exactly at the same point, whether I'm making a backside or a foresight, to measure an angle or to lay out something. If the sight picture differs, my angle measurements are going to be off. So sight picture cannot be over exaggerated. So now I'm on my target. Now I can flip the locking lever up, and if I unlock the horizontal and turn to another target, and I've got a target up here on the door casing, that is. So now I'm going to get exactly on my target. I'm going to lock the horizontal, use the tangent screw, lock the vertical, use a vertical tangent screw, and now I have the sight picture that I want. Then I look through the small scope, and I adjust the light, and I adjust the focus of the small scope to read the angle. And this time I'm reading 56 degrees, 19 minutes, and 20 seconds. Now then, I record that in my book. That's what we call our direct angle. And I've got a short memory, so 56, 19, 20. 56 degrees, 19 minutes, 20 seconds. Now, to ensure that I have turned an angle or made that measurement properly, we know that as fine as this instrument is built, not all the axes are perpendicular to each other. Because we're humans, we can't manufacture perfect instruments. So whatever the instrument is off in one direction as an exaggeration, when I do the reverse angle, I'm going to make it off the same amount in the opposite direction, which is like splitting the difference on the bubble. And then we're going to average those angles, and what it should come back to, it should nullify the error and come back to perpendicular. So to do that, I've made my first observation. I lock the lever down, I unlock the vertical, and I flip the scope upside down. Now, my 56 degrees, 19 minutes and 20 seconds is locked into the instrument with the lever down. That will not move. I now move the horizontal, and now I go back to my original target. Now I've got the same sight picture. I now flip the lever up. I unlock the horizontal, and I turn to my next target. I'm repeating this angle, and this is called turning multiple angles, direct, and this is now what we call the reverse. I'm going to divide that angle by 2, and it should come back approximately to my original angle. In theory, if we divide our reverse angle by 2, or if I lock this, turn it 3 times, flop the scope, lock it, and turn it the 4th time, which is what we call double direct, double reverse, I would divide my double reverse by 4, or my reverse angle by 2, and I should have a more precise measurement by statistics. Dismount the instrument, we simply undo the screw on the tripod, bring back over here, and this particular type of instrument is somewhat contrary to get back in the box. We have the locking lever, fits in a little cradle here, and this long tangent screw fits in this cradle. So it only fits in one way. Put the levers down, snap them in, the case on top, snap those. Now the instrument's home.